All right, inverses of functions. Inverses of functions simply means swap x and y. Okay, when we're looking at a graph, it means all of our x values and y values are going to swap. When we're looking at points, they're going to swap. When we're looking at an equation, they're going to swap. So for example, if I have a set of ordered pairs, maybe that's my set of ordered pairs, all right? And they ask me to find the inverse of it. Well, that just means simply swap x and y. So now this point becomes -4, 2. This point becomes 5, 7. This point becomes 0, -1. And this point becomes -5, 10. We did not change the sign. I didn't do anything else. I put the y value in for x. I put the x value in for y. That is all we are doing when we're finding inverses of functions. So that's how to do it with a set of ordered pairs. How to do it with an equation. Let's say we start off with an easy equation, y equals 5x plus 7. Well, what's the rule with inverses? Swap x and y. So that's what I'm going to do first. X equals 5y plus 7. Now, once I have that, I've got to solve for y. So I'm solving for the variable that's right there. So I subtract 7 from both sides. So now I have x minus 7 equals 5y. Now I divide the entire thing by 5. Please don't put it over each, just put it over the entire thing. So now y equals x minus 7 over 5. How you can write your final solution is two ways. We can write it y negative 1 equals x minus 7 over 5. That means y inverse equals x minus 7 over 5. If we want to write it in function notation, we can write f inverse of x equals x minus 7 over 5. All right, so either of these two work. I'm probably going to stay right here with this solution for right now, just so that we don't get into function notation a whole lot. But if they want it in function notation, then that's your function notation. So it just means swap x and y, solve for y. Let's look at a different problem. Let's go with something like 3/4 x, or y equals 3/4 x plus 9. Okay. Again, first step, swap x and y. So x equals 3/4 y plus 9. Solve for y. Subtract 9. X minus 9 equals 3 over 4y. Now, to get rid of the 3 over 4, what you need to do is to multiply by the reciprocal. So I'm going to multiply both sides by 4 over 3. Notice I didn't change the sign. I just simply flipped it upside down. So now I distribute the 4 over 3, so I get 4 over 3x minus, remember this is over 1, so that's minus 36, or 36 over 3 equals y. Now rewriting y equals 4 over 3x. Guys, simplify this. 36 divided by 3, 12, so this is minus 12. So final solution, y inverse equals 4 over 3x minus 12. All right. You could have also left that solution as, let's just say, right here. Instead of doing it like this, we could have said, hey, this is 4 times x minus 9, all divided by 3, if that's the way you want to write it. And that works for me just fine. Either way that you want to do that. So instead of multiplying and distributing it out, you can just leave it like that. Does not matter to me. All right. So let's look at a different problem along the same lines. So maybe that's our problem this time. Again, swap them. X equals 2 over 5, y minus 7. Solve for y, which means I need to add 7 first. So x plus 7 equals 2 over 5y. If you want to look at this as a multiplication and division problem, that means I need to multiply by 5 first. So I have 5 times x plus 7 equals 2y. Divide by 2. So now I have y equals 5 times x plus 7 divided by 2. Different way of doing the problem. If you want to multiply by the reciprocal again, that works out just fine. So I have y inverse equals 5 times x plus 7 over 2. It really doesn't matter to me how you want to write that solution. That is going to be your answer. If you did the reciprocal way, you'd end up with 5 over 2x plus 35 over 2. Those are the same exact thing. So depending on which way you want to write your solution, that's fine with me. Let's look what happens whenever we have maybe an x squared in the problem. So y equals x squared plus 5. Okay, swap x and y. Subtract 5. X minus 5 equals y squared. The way we get rid of squared is take the square root. But remember, anytime you take a square root, you have to do plus or minus. So I end up with y equals plus or minus the square root of x minus 5. And so y inverse equals plus or minus square root x minus 5. That would be my solution. Slightly different from a problem that might look like that. Swap them. Now, notice that everything's underneath the squared, so that means I have to take a square root first. So I get plus or minus square root of x equals y plus 5. Now I solve for y by subtracting 5. Y equals plus or minus square root of x minus 5. And then make it an inverse, and that would be your solution. So slightly different. Go back and watch this again. Check and see what I did there. Slightly different way of solving those two problems. One more type of example that I want to give you is what happens when maybe they restrict our domain. Something like that. So here's what happens. So swap x and y. X equals square root of y plus 2. And I actually want you to swap it over here as well. It was a y, so now we're going to make it an x. Now solve the equation. Subtract 2. X minus 2 equals the square root of y. To get rid of the square root, we square both sides. But remember, you need to put parentheses around it and square that side. Y equals x minus 2 squared. And then we have x greater than or equal to 2. All right, and that keeps your domain, or keeps it all in the same spot. So if they give you a domain restriction or some sort of restriction out here, just swap x and y around and that gives you the same solution. All right, so with inverses, swap x and y, solve for y. If they give you a set of ordered pairs, just swap x and y and that would be your solution.